So I will do this presentation of the second tool, the Bioconnect tool, a little bit shorter to stay in time. So the Bioconnect tool sorry, this map is jumping a little bit at the moment. Let me reload. So the Bioconnect tool basically has a landing page where the user can pull different layers from different services, for example, like the Catalan land use, land cover map, where you can see that areas in red, for example, are built areas in the Catalan area. Then we have in green forest land, blue aquatic, woody cropland as this pinkish color. And the user can look at this map and get a sense of the land use, land cover, or land use in the area of Catalonia, and then also choose different layers, like the satellite images can pull up roads and railways, rivers, water bodies, all these different layers that are presented on the left side of the tool. The main point of the Bioconnect is connectivity indices that the user can visualize on the map. So for the Catalan area, we have connectivity index maps for aquatic forests, herbaceous crops, woody crops, and shrublands. And these different maps always indicate how easily a terrain can be traversed with an index number that, for example, let's see here, there is a city, and in the city center, you can see that the bioconnectivity values are so very low, so they cannot be traversed. And in this forest land, for example, they are have a higher value, which you can, for each pixel, look up, so the user can get an idea of how structures or man-made structures or natural structures interfere with bioconnectivity. And the great asset that is actually given by this tool is a scenario creation. So on the scenario creation screen, we can, I will do an extreme example to very easily show you what this does. You can, in some point in the map, zoom in into a location you're interested in. Let's see, let's take some area which is, let's take this part of a city infrastructure. So you can see this is a red building area. And now I want to see how the bioconnectivity changes if I, for example, take this suburban area and then draw a polygon around it, and I can then choose that I want to see how the bioconnectivity index for a forest changes if somehow this city area is converted into a lake, let's say. So the city is not there anymore and is supplemented by a lake. I can choose a processing mode which defines the model that is used in the backend at the Atos partner. So for the forest land, we can use a high resolution model and then save the scenario, and it will post a request with the changes that we made in the area to the Atos backend, and then we get a connectivity index change returned. So on the left side, you can see our initial map in a different resolution, unfortunately, than on the right side. But you can see on the right side in the very center, when I zoom in, that we have now an area where previously our city or our urban area was. Now we have an area where the connectivity index that is newly calculated displays that this is not traversable because we changed it into an aquatic land use. So there's actually a lake now, and the basis for calculating of the index is that this is not anymore in suburban area, but a lake. And this is an extreme scenario, of course, and which does not make much sense, but it highlights on the functionality of what this calculation does. And now, if we are active in the area of Catalonia in policy making, we can actually use this scenario creation screen and check how our planning or our policies affect any areas that are presented on this map. So we can draw any type of polygons on the map, say in what land use we want to convert the area. So we can also say this is previously a cropland and our city planning wants to convert that into a forest. And then we want to also introduce a forest down here for any reason. And we can select this polygon, so the policymakers or city planners can actually introduce new structures into the map of land usage, and then calculate what effect this does have on the different bioconnectivity indices, which can be selected in the API parameter. And before a structure is introduced or a massive change is done in urban or suburban planning, see how does this affect the surroundings of the area that we are changing, and maybe also for environmental purposes, how can we improve some of these indices by introducing changes, for example, from a cropland to a forest, or from a forest to a cropland, and vice versa. And so interact with the map and get an idea how can we use this tool to make more informed policy changes. That is the idea. And of course, the ability to look into all these different layers of the Catalan area and investigate what is the current status of land usage and connectivity in the different indices that are provided.